Good morning, majors. This is Unit 3, Day 6 notes, and we're going to go over velocity problems in 2D. So we're going to revisit the ice cream truck. Recall our ice cream truck problem from a few days ago. The ice cream truck started off at noon at a point 2:20, so right here, and every hour it moved for -3. And remember, that is always the x values 4, and then y value is 3, -3. It says the vector for -3 represents the direction vector. We went over this last time. And this is going to be the magnitude of 4, -3, which is the square root of 4 squared plus, and then -3 squared. Just remember that anything negative, when we square it, becomes positive. So that is 16 plus 9, which is the square root of 25, which we actually know is 5. So the velocity of the ice cream truck is 5, and I think we're in like miles per hour, every hour, and the distance is in miles. Okay, good. So I didn't want to assume, but we're in miles per hour. In the direction of the 4, -3, this vector. The speed of the ice cream truck is 5 miles per hour. And the speed is a scalar. But the velocity is a vector. So this, the velocity is going to have a magnitude, and it's going to have a direction. Okay. It says if I just want to make sure I answered that. Really, I just want to dissect that sentence. So if A to B, or AB, is the velocity vector, of a moving object, then it is traveling at the speed of, and we use these symbols for magnitude, and then we just have our vector AB. Whatever the magnitude is of this vector, which is equal to the square root of a squared b squared plus b squared in this 2 dimensions in the direction of AB. So this is my direction vector. And we're just the direction vector. And we're just taking the magnitude of it. We're finding the magnitude of it. It says, suppose a body or object moves with the velocity vector B. If the body has an initial position vector A, when time, let's say our time is equal to 0, our initial time, then its position at time t is given by, okay, so our position vector is given by our initial vector plus time times our velocity vector or directional vector. Let's do an example. Let's just write an example here. Our xy is equal to, and our initial point, let's just say 220 for this case, up here. Remember, this is our initial. Plus t this is a t, times our direction is -4, 4, -3. This is the direction. When our time is greater than or equal to 0, we're not going to have negative time. It can be 0 though. So when our time is 0, that's just our initial point. Position at time t of the ice cream truck. Because imagine that an ice cream truck starts at 7:2 and moves with the velocity vector 6, -8, where t is measured in hours. Distance units are in miles. Okay, we're in miles, good. So hours and miles, find the vector equation of the position of the ice cream truck in the form r equals the initial plus the time times the direction vector. So we kind of already did this, but we have this new information. So imagine that an ice cream truck starts at 7:2. So this is my initial right here, 7:2. And I see that there's only 2 variables. So I know I'm only going to have x, y equals, remember a is my initial, so this is 7:2. And then plus our time times the directional vector. Do they give us a directional vector? Velocity vector of 6, -8. Okay, well this is going to be our direction also. Let's write direction underneath it. Okay, so we have 6, -8. There you go. The speed of the ice cream truck. Find the speed of the ice cream truck. Remember that the speed is the magnitude of my directional vector. So we just went over this. My directional vector is 6, -8. And I'm actually going to find the magnitude of it. This is a symbol for magnitude, these lines. So that is the square root of 6 squared plus, and then -8 squared. 6 squared is 36. -8 squared is 64. I believe that is 100, which is nice. That's just 10. So 10 miles per hour. Remember, this is a scalar. Speed is a scalar. So we don't have a vector. C, it says the position of the ice cream truck when our time is 2.5. Well, we can actually find out what our position is going to be when our time is 2.5. We have our equation. So what is x and y? What is my position? What is x and y when we have 7:2 as my initial plus, well, my time is 2.5 times my direction, which is 6, -8. We're going to have to multiply 2.5 times 6 and 2.5 times -8, and then add those to the 7 and 2. Okay, so what I did is I multiplied 2.5 times 6, and I know that's 15. 2.5 times -8 is -20, and then I'm just going to add them. So 7 plus 15 is 22. And 2 plus -20 is -18. And this is going to be the position of the ice cream truck when our time is 2.5. This is my position. The time when the ice cream truck is located at 31, -30. So they're telling you what my position is. So 31, -30 equals 7 to, and then plus t times 6 negative 8. Okay, well, we have this equation now. I know that 31 equals 7 plus 6t. And you can just solve for t. So subtract 7 to move it over, which will give you 24. Divide by 6, and t will equal 4. You can do the same for the bottom one, and you're going to get 4 hours. In 4 hours, that's going to be my position. Go ahead and flip that paper over. Let's just try a couple more problems. It says, find the velocity vector of a speedboat moving parallel to -5, 12. Parallel gives me my direction. So direction. This is my direction vector. With a speed of 65 kilometers. Ooh, this is my magnitude. Okay. So I know that B, the magnitude of B, equals -5 squared plus 12 squared. And that is 25 plus 144. And that is 169, which is 13. Okay, they're asking us for the velocity vector of a speedboat. So I know I might need to multiply this by a scalar because I want it to equal 65. So I know that 65 is equal to k, we don't know what this is, times, I think we got 13. I just have to divide by 13 and I see that k equals 5. I know that this is my directional vector. So what I'm going to do is say my directional vector, or my velocity vector of the speeding boat, is going to be 5 times my directional vector, which is -5, 12. Oops. Which I think it gives you -25 and 60. Check, make sure. This is my new vector. That's it. Circle it. Find the velocity vector of a speedboat moving parallel to this with a speed of 50 kilometers per hour. So we're going to do pretty much the same thing. They just put it in a different form. So I know the magnitude of -3, 4 equals the square root of -3 squared plus 4 squared, which is 9 plus 16, which we know is 25. So this is 5. So I know that I want the speed to be 50 equals k times 5. And I can divide by 5 and say k is equal to 10. And then we're just going to multiply that by the by our directional vector. This is my directional vector. So I have this time 10 times the -3, 4 is -30, 40. That's it. I'm going to write it in the same form because they had it in the unit vector form. So let's just write it in the right form. So we're going to put -30i plus 40j. A yacht moves according to this, where the distance units are kilometers and the time are hours still. yacht B moves according to this, okay, where time is greater than or equals 0. Find the initial position of each yacht. So this one's pretty easy. We have our initial positions are going to be for yacht A is going to be 4, 5. And for yacht B, it's going to be 1 and -8. Find the velocity vector of each yacht. So those are going to be the ones with the T's. My velocity vector is going to be for A is 1. If there's no number by that T, there's 1, and -2. And B is 2, 1. Find the speed of the yacht. Remember, that's just the magnitude of my directional vector. So we have the magnitude of A, which is the square root of 1 squared plus -2 squared, which is the square root of 5 kilometers, I think, per hour still. And the magnitude of B is 2 squared plus 1 squared, square root of 2 squared plus 1 squared. Oh, they're actually the same. Okay. Find the time when the yacht A will be directly east of the origin, 0, 0. Okay, so I just kind of plotted the initial position for yacht A. That's all they're asking us for. It's at 4, 5. And then the direction of A is to the right 1 and then down 2. So to the right 1, down 2. So they're just asking when it's going to be directly east of the origin, which is going to be on the x-axis. And when we're on the x-axis, y equals 0. Okay. So we're going to say, well, when x 0, when my position is, we don't care about the x value, but we're trying to find that. But when my y value is 0, then, you know, our initial position is 4, 5, my vector, plus time times my direction, which is 1, -2. And what I'm going to do is I'm just going to solve for time. So we have, I'm going to use the bottom one, 0 equals 5 plus t times -2. So minus 2t. And then I just need to move this 5 over. So -5 equals -2t. Divide by -2. Time is 5 over 2. So 5 over 2 is approximately 2.5 hours. Perfectly. 2.5 hours. Where will yacht B be when yacht A is directly east of the origin? So when time equals 2.5. Well, I can make my my equation. Yacht B's equation is xy equals my initial, which is -1, 8. Or 1, -8. And then plus, we know that our time, we want our time to be 2.5 the same time. And then my velocity vector is 2, 1. This is our direction. So all I have to do is solve. I know that when time is 2.5, x equals, and I'm just going to stay on top, x equals 1 plus 2.5 times 2, which is 1 plus 2.5 times 2, which is 6. And then y equals -8 plus 2.5 times 1. So negative 8 plus 2.5 times 1, which is negative 8 plus 2.5, which is negative 5.5. Check, make sure. So my position is going to be at 6, negative 5.5. Find the position vector of yacht B relative to yacht A. So remember that AB, just like this, is B minus A so AB is B. It looks like B's equation is 1 plus, and then this is usually T times 2. So 1 plus 2T, and then negative 8, the initial, plus my direction, which is 1 times T, or just T. And then minus A. A's is right here. So we have 4 plus T times 1, which is T. Oops, I put T. 4 plus T. And then the bottom one is 5 plus negative 2T, so 5 minus 2T. And we just have to subtract these. Don't forget to distribute this negative sign. So I have 1 minus 4, which is negative 3, positive 2T minus T, which is T. Negative 8 minus 5, which is negative 13. T minus 2T is 3T. Therefore, AB is negative 3, negative 13, plus T times 1, 3. Whoops, pretend like that's a 3. Alrighty. Okay, one more, guys. Using F, if they start at 6 a.m., find the time when the yachts are closest to each other. Okay. So at 6 a.m., if they start at 6 a.m., that means this is when our time equals 0. Closest to each other means that the distance between is at a minimum. And we know the distance between them is the magnitude of this, which is AB. Is at a minimum. But we can find the distance or the magnitude of AB. Oops. And then we're going to have negative 3 plus T squared plus, and then negative 13 plus 3T squared. Unfortunately, we have to FOIL this. So I know that this is going to be T squared. Negative 3T minus 3T is negative 6T. Negative 3 times negative 3 is negative 9, or positive 9. So we have to FOIL it. Write them next to each other and FOIL it if that helps you. Plus 13 times 13 is 169. Minus 3T times 13 times 2, I think is negative 78. Try it out. and then plus 9t squared. We have 10t squared minus 84t plus 178. Okay, so what I would do is actually graph this to find the minimum point. So we're going to graph this. And then what you can do is use calc and then go to min, and it'll actually tell you what the minimum point is. You're gonna have to do a left hand and then a right hand bound, and then it'll tell you what that minimum spot is. So it looks like when our t is equal to 4.2. In order to find out what 0.2 is, to find out how many minutes, we know this is 4 hours. But how many minutes 0.2 is, we're going to have to multiply this by 60. What is 0.2 times 60? I think that is 12 minutes. Okay, therefore we know that it's at 4 hours and 12 minutes plus, it starts at 6 o'clock. So 6 plus 4 is going to be about 10:12 a.m. That's it. Oops, sorry. Alrighty guys, if there's any other problems, go ahead and try them out. And I hope you guys have a great day. I'll see you in class.